of against it. Can we get 10 likes? So let me get that mop. Where's that mop? So that was the issue, is that people kind of sort of really did not like the fact that the mathematical prediction allowed for black holes to be a thing. Einstein didn't like it. I think there was this guy, I believe it was Eddington, who also did not like it. Chandrasekhar tried to work on them, but I think he was stomped down on, and so he did not continue working on black holes. But he did contribute, of course, to the Chandrasekhar limit, as we know, with white dwarfs. So I'm saying these words, which I hope that you will look up and learn them in more detail, because I'm not covering every single detail, but I'm giving you the points that you can then Google and whatnot. And if you have any questions, as I keep saying these things, you should ask them. So anyways, we saw how Chandrasekhar was kind of bullied out of working on the black hole stuff. That can happen in academia. Sometimes people are not very nice. And if they don't like what you're working on, they bully you a lot. And you might just give up on something. So, but then there was more studying of this phenomena, and people actually found in observation, if you experimentally find black holes, then nobody can deny them. So people actually found black holes to be a thing that actually did exist. And so turns out that yes, sometimes certain even more bigger stars, even more massive stars, will have an extreme collapse all the way down to a black hole, which is basically an even more compressed object and has a very strong gravitational field which curves space-time, so much so that even light cannot escape from its event horizon. Event horizon is a part of the black hole, and there is some math that goes with the black hole with general relativity, and there is this thing called Schwarzschild radius. Schwarzschild was the guy who actually took Einstein's equations and solved them for black holes, and he was very successful in doing this. And so we say that basically if you take a massive object and you compress it down to its Schwarzschild radius, then it becomes a black hole and even light won't escape it. So you basically set the escape velocity from this object to the speed of light. And that's how you do the math. And it actually kind of simplifies the math. All you have to do is not let light escape from this thing with some mass m, and out you get the Schwarzschild radius, which will give you the radius of the black hole. So anyway, you asked how black holes work, and this was my long-winded answer because I cannot give too much shorter of an answer. This is already quite short, actually. There's even more details that one can learn about black holes and Schwarzschild radius and general relativity and all the ways in which you can make one. Well, really, actually, you would have a star dying and getting compressed down to a black hole. That's pretty much how you make one. But then this does not include, I didn't say too much about supermassive black holes. Those actually happen because a black hole keeps on eating more matter, and there is more material from its surroundings that's falling into this black hole. Over time, it becomes bigger and bigger. So that's the other little sentence on supermassive black holes. But in general, when somebody says black hole, we would imagine that they mean the stellar remnant option. So when stars die, there's three options: becoming a white dwarf or a neutron star or a black hole. And that's how a black hole is made. Okay? So thank you, Austin, for that